In this part, we will be discussing about one of the most important topic in thermodynamics, that is first law of thermodynamics. What is first law of thermodynamics? The first law of thermodynamics states that energy can be neither created nor destroyed, right? So you might already know this fact that energy can be neither created nor destroyed, and the whole concept of first law of thermodynamics is based on this logic of energy and matter, right? Next, yes, you know that it can be transformed from one form to other. You know that energy and matter can be transformed from one form to other form, right? But overall energy and matter remains conserved, right? So the whole concept of first law of thermodynamics deals with this concept, right? Yes, you also know this logic is called law of conservation of energy. Now let's get into the mathematical expression of first law. Let U be the energy of the system in its state A and UB be the energy of the system in its state B, right? So consider system. Let's get out to our old example, the best example, right, and easy example, right? So consider UA be the energy of the system in the state A, right? So let it be in state A, and we have discussed such example, right, where a system can be undergone from one state to other state, right? And this is the state B of the given system. And consider, if suppose these are the there are gas molecules present in the system, they have certain energy associated with this, right? And consider the total energy of the system is UA initially, and because of some reasons, because of heating or might be some other reasons, the same system is undergone to a change to a system B. Now it is a system B because of some changes, maybe because of heat, right, maybe because of work done, you will understand them, right? But the total energy of the system is now UB, right? So this is the first point. Next point, suppose the system while undergoing change from state A to state B, right, state A to state B, absorbs heat from the surroundings, right? So what is happening, friends? This transfer is happening because of absorption of heat from the surroundings, right? The system is observing this heat from the surroundings, right, and going to the state B. So Q be the heat absorbed from the surroundings. Next important point, the absorption of heat by the system tends to rise the energy of the system. Obviously, right, friends? So these are the gas, if you consider these are the gas molecules. So these gas molecules, now what happens? They take the heat, right? They take the heat and they they vibrate it at higher rate now, right? These gas molecules take this heat and they start vibrating at higher rate, right? So what happens now? Because of this, the total energy of the system also increases. So absorption of heat by the system tends to raise the energy of the system also. Because of this, UB will be greater than UA because of the absorption of heat Q. Next, the important parameter, the very important parameter is the work, right? So the performance of work by the system, on the other hand, tends to lower the energy of the system because performance of work requires expenditure of energy. So I can tell you in a nutshell that this heat, right, is also used in expansion of the, right, expansion of the piston from state A to state B. Here the system, here the piston is changing from the state 1 to state 2. That means what is happening, friends? Right, here the performance of the work done by the system, right, it is tending to lower the energy system, right, because performance of work requires expenditure of energy. Since performance of work requires expenditure of energy, right, there is a trend or a trend which lowers the energy of the given system. So what is happening, friends? Hence, what is happening now? The change of internal energy is accompanied by the processes which will be given by this process or this equation of first law of thermodynamics, right? So what you have to understand, friends, here is I am supplying heat, right? Yes, this is also, you can see here I am supplying heat, and how this heat is utilized? This heat is utilized, the first part, it is utilized in change in the total energy of the system, and it is also used in work done, right? So there is work happening, and also simultaneously there is change in internal energy. This energy is the total energy of the system, is also called internal energy, is also called internal energy, right? So you can see here how my performance of work is expending the energy, right? So you can see here how my performance of work is expending the energy with this equation of first law, right? So what is Q here? Q is the heat transferred to the system, right? You are transferring heat to the system. Next, what is W? So W is the work done by the system. Yes, the system is doing the work, right? It is taking the piston from stage 1 to stage 2. Next, what is also happening? There is change in the internal energy of system, which you already discussed, right? So what is important, friends, is here work is compensating the internal energy and the heat. Here work is compensating by the system by doing work, that is by raising the piston, right? And it is thus compensating, or that it is lowering the energy of the given system. So the energy of the given system is lowered by doing work. So friends, here you can understand clearly in a better way, right? So the change in internal energy is because of heat and work done. So remember, friends, these are the very important, this is a very important notation. Suppose for the given system, suppose the system here is, right, suppose you are taking heat from the surroundings, that is notated by plus Q, right? So if it is heat transferred to inside the system, that is defined by plus Q. Next, heat transfer out. If it is exothermic process, right? So what is happening now? There is a heat transfer from the system. Such heat is now considered to be negative, right? So if it is heat is given to the system, it is plus Q, and if it is heat given out from the system, it is minus Q. Next, friends, if work is transferred in, it is plus W. That means, and work transfer out, it is minus W. That means if the system itself does work, here what is happening, friends, in the above example, the system itself is doing work, right? So it is going from first stage to second stage. The piston is going from first state to second state. So what is happening here? The system itself is doing the work. That means the gas molecules itself are doing the work, right, in raising the piston from 1 to 2. In this case, work done will be negative because work is transferred out. I already discussed, right? I discussed that this work done is actually lowering the energy of the system. How it can be lowered? It can be lowered by the negative representation, or the negative representation of the work done, or through work transfer out from the system. And imagine if there is a situation in which an external force is doing the work and it is compressing. An external force is doing work and it is compressing, right? So if it is the stage 1 and it is the stage 2, and suppose this external force takes the piston from stage 1 to stage 2, and in this case work is transferred inside the system, right? So that in that case you will be representing it by positive W, right friends? So it depends on whether the system itself does the work or if any other factor or any other force does the work, right? If the work is done by the system, it is minus W. If the work is done on the system, it is plus W. So this is about the first law of thermodynamics, right friends? So remember these notations, they are, don't forget these notations, plus Q and minus Q. In what happens in endothermic, it is plus Q. What happens in exothermic is, it is minus Q. What happens if work is done by the system, it is minus W. If it is work is done on the system, it is plus W. Hi friends, so for any further doubts, you can open askIITians.com and you can find the discussion board, and if you click on it, you will get Ask Experts on the right side of the screen, and you select the category accordingly. So thermodynamics belongs to physical chemistry, and you can post your question here. We experts at askIITians will be reverting you back within 24 to 48 hours. Hi friends, this is all about first law of thermodynamics. We have learned the importance of heat, work done and change in internal energy of a given system. In the next topic, we will be learning some more interesting topics. So keep tuned friends. Goodbye. Have a good day.